Hi everyone, this is a video on how to find critical values. You're going to want to watch this before you attempt homeworks number 16 and 17. So let's take a look here at what exactly is a critical value. So as you know, the probability of any situation we're looking at, the percentage of the population that lies under the normal distribution curve is 100%. Talked about that a lot in class. Well, suppose I want to find the middle 95%. Let's see, where does 95% lie? Right smack in the middle. So I actually have two boundaries. I have one right here, and I have one right here. And that is all a critical value is. It is what we have done in the past using our z-table in the reverse where we know the area under the curve but we don't know the z-score. And it is between this. All right, so we have two z-scores we have to find because it's not all the way out to either negative infinity or positive infinity. That's not the 95%. It's this middle 95% of our population. All right, so what are those cutoffs? What are those boundaries? What are those critical values? All right, so as you know, we're going to have to use the z-table, and we are told that this area is 95%. So the first thing we're going to do is change this into a decimal because that is how we use the z-table. So this is 0.9500. We carry it out to 4 places because that's what our z-table does. Now we don't want to go to our table because our table, remember, our z-table always, wherever your z-score is, doesn't really matter, it gives you all to the left all the way out to infinity. Okay, so we don't want to go there until that's something that we have. But let's take a look then. What is this space here? And what is this space over here? Well, we know they're the same area. They're the same percentage because we're looking at that middle 95%. So the remainder is over here and over here. Okay, and so to find that blue area, we would take the 100%, which is the area under the total curve, and subtract off that 95%. All right, and what do we get? We get 0.05. 0.05 is our two blue areas. All right, and we call those two blue areas, the area outside of what we want, call that alpha. It's a Greek letter, and that's all it means. It's not anything intimidating at all. We just call that alpha. And because half of alpha is here and half of alpha is over here, what we need to do is divide alpha by 2. All right? And that's going to equal our 0.05, our 5%, divided by 2. Do that on your calculator. You're going to see that's 0.025. And I'll add that fourth decimal place, which is a 0. In other words, this is 2.5%. 100% minus 95% is 5%. 2.5% lies on this side, 0.0250, and 2.5% lies on this side, 0.0250. And that's all this is. This is just considered alpha over 2. All right, it's just symbols. All right, alpha over 2. And that's where this symbol here comes from. And the reason we need to write it, the reason it's important to write it, is it carries into what we're going to be doing in future problems and videos. All right. So what do we do from here? Well, now we know the area under the curve, and we need to find the z-score. So let's see. I'm going to find this critical value right here to the left because it's the areas to the left of my curve, and whatever I discover this to be, it's going to be the exact same number over here, just the positive version. All right, so we know this is on the left-hand side and of the mean, and we are going to go ahead, therefore, and pull up our negative z-table. Okay, so let's do that. Here it is. And now what I'm looking for is 0.025 under the curve, And guess what? Look at this right here. Oops. Okay. It's right here, 0.025. 0.025. It's right here. Okay. Whoops, lost my pen. All right, 0.0250. I don't know why I can't get that. Here we go. 0.025. Here it is. Okay, 0.025. And you can see that the z-score that corresponds with that is minus 1.96. Okay, 1.96. All right, so let's z-score here. Negative 1.96. So this one over here must be positive 1.96. And that's it. So our critical value, or z alpha over 2, equals either the positive or the negative 1.96. We have two critical values, obviously, this one here and this one here. All right, and that's how you find critical value. Let's try one more example. All right, let's try one where the area under the curve that we're looking at is 85% rather than 95%. What are these critical values? These are our two critical values. What are they? Alpha over 2, that's how we define them, alpha over 2. All right, so this area under the curve is 85%. We write that as 0.8500. So the first thing we need to do is find our alpha over 2 space. We have alpha over 2 here and the other alpha over 2 here. We know that the total area under the curve is equal to going to equal 1 minus the 0.8500, and then that is going to be divided by 2. 1 minus the 0.85 is the remaining 0.15, the remaining 15% divided by 2, which equals 0.0750. Okay, so just changing my color here, we know that 7.5% of our data is under here, equals 0.0750, and the other 7.5% is over here, equals 0.0750. All right, so that's what lies under the curve. I'm going to go ahead and find this magic z-score here because I know the area under the curve. So I'm going to go ahead and pull that up, and let's pull up that z-table. Oops, let's turn that off. Okay, so now what I'm looking for is that 0.075, and sometimes you can't find that exact value. We have to approximate, right? We have to. So I find here 0.07. 0.07, where is it? 49. Okay, here's the spot right here. Okay, 0.0749. All right, let's be right here. 0.0749 right here. Okay, right here. 0.0749. That's as close as we're going to get to 0.0750, and it looks like the z-score for that is minus 1.44. All right, so let's just turn that off. Come back to our work here. So it's going to be equal to, turn that off, come up here, sorry, equals minus 1.44. Still have my blue pen, that's going to be hard to see. Let's switch. And this one over here is 1.44. This is the negative 1.44. All right, so our critical value, which is what we were asked to find, our critical value, which we write as z alpha over 2, is equal to the positive or the negative z-score of 1.44. All right, so that's how we find critical values, guys.